Hi friends, welcome back. Today we're talking about rational functions, graphing rational functions. We're talking about finding those vertical asymptotes. Just a reminder, an asymptote is a line that when you're graphing, you don't cross it. It's a little more detailed than that, but we'll get into it as we go along. Okay, so the first thing that we want to do is take a peek at our first question here. So in order to find our vertical asymptotes, you set your denominator equal to 0. And this is important because a vertical asymptote is a vertical line on your graph. And you want to write this as the equation of a line. So you don't want to just say 3, you want to say x equals 3. So if you set your denominator equal to 0 and solve for your x's, that will help you do that. So let's take a peek at our first question here. Find our vertical asymptotes, y equals all this garbage here. So here's what you do. You want to set your denominator equal to 0. So if I go ahead and do that, I say, okay, x squared minus 4 equals 0, right? So now all I have to do is solve for 0. And in order for me to do that, I'm going to add 4 to both sides. So I do plus 4, and I get x squared equals 4 square root, and x equals plus minus 2. So that means that my vertical asymptotes are at x equals 2 and x equals negative 2. So what does that look like on the graph? Well, I go over 2 and I go over 2 here. And so I don't need to put a dot. I just need to put my little draft lines here. So you'll make some dotted lines just to show your asymptotes. This helps when we're graphing, and we'll get more into that a little bit later, but having those dotted lines there will really help. So let's take a look at what that guy actually looks like. So if you're not familiar with it, you can go out to desmos.com, looks like this, and you just click this graphing calculator in the center. And then all we do is type our equation or our function into our graph. And I've already done that for you. So here we go. We look at this one and you can see, remember our vertical asymptotes are at 2 and negative 2. And sure enough, if you follow this 2 line, you can see, and as I zoom out here, you can see that it is not crossing at the 2 or the negative 2. They're both getting really close, but they are not crossing them. And that's what an asymptote is. So let's take a look at our next problem. Okay, so for our next guy, we've got y equals x squared plus 11x plus 18. All of that is divided by 2x plus 1. So our vertical asymptote is 2x plus 1 equals 0. Minus 1 from both sides, I get 2x equals negative 1. Divide both sides by 2, I get x equals negative 1/2. So again, I'm just setting my denominator equal to 0. So at negative 1/2, that's right here. We go ahead and put an asymptote in there. Okay. And if I were to graph this guy right here, let's take a look back over here. And sure enough, you can see at 1/2 here, negative 1/2, I'm sorry, it's getting real close to there, but it's not crossing. Even if I go all the way up here, it's going to get real close to negative 1/2, but it's not going to cross it. Okay, let's take a look at our next one. So we have this guy right here, x squared plus 9, and then over x squared minus 2x minus 15. All right, now it's important that you factor when possible. I should have shown you that up here as well, because if you cancel anything out, we'll deal with that in another video, but if you cancel anything out, it is not an asymptote. So looking at this, I can't factor the top one, and down here it's going to be 5 and 3, so x minus 5 and x plus 3. Cancel that out. This is x squared plus 9. And now if it was minus 9, that would be different, but it's plus 9. So there's nothing that I can cancel out here. So we're good to go. We can just do our vertical asymptote. Now, again, we set the denominator equal to 0, and conveniently, I've already factored it for us. So if I set it equal to 0 and use my 0 product property, x minus 5 equals 0, which means x equals positive 5. I probably should move this up here. Vertical asymptotes. X equals 5. X equals negative 3. So I go over here to positive 5 and I draw my line like this. And I go over here to negative 3 and I draw my line like this. And sure enough, let's take a look at this next one. We have got this guy right here. So again, you'll see at negative 5 right up and down here, and over here, I'm sorry, at negative 3. I don't know how to count today. At negative 3 and then at positive 5 over here, those, it's getting real close, but it's not actually crossing. See that +5? I think it's a little easier to see now that we have that line. Okay, let's do one more and then we'll call it good here. So if we've got this guy right here, let's see, y equals x squared plus 3x plus 2 over 2x squared. Okay, so we got to factor this guy. Let's just go ahead and do that. So if we do that, we do x plus 2, x plus 1 over 2, x squared minus x minus 6, which will give us 2x plus, this tells us different signs. So it'll be x and minus, and then minus 3 and 2, because 2 times 3 will give us 6, and then -3 plus 2 will give us -1 there. Okay, so in this case, look at that. We do have something to cancel out, this x plus 2. So if I cancel those guys out, that's called a hole, and we'll talk about that in a future video. Vertical asymptotes. That means 2 times x minus 3 equals 0. Using my zero product property, 2 does not equal 0, so that doesn't, we don't need to worry about that. X minus 3 equals 0, x equals 3, +3. So I have a vertical asymptote at +3. I do not have one at -2. That's why it's important you factor so you can see that. Let's take a look. Sure enough, you can see I have a vertical asymptote at 3 right along in here, but I do not have one at -2. Hopefully you found this video helpful. We'll see you next time.